Welcome to our journey through neural networks, exploring key concepts and their transformative impact across industries. Neural networks have carved a niche in automating and interpreting complex patterns by mirroring the human brain's function. From healthcare, enhancing disease diagnosis, to finance, improving trading algorithms, their impact is profound and wide-reaching. This journey began with simple perceptrons, which laid the groundwork for understanding basic decision-making processes. As we progressed, more sophisticated models like feed-forward networks, convolutional neural networks, and ultimately transformers have allowed for nuanced interaction and interpretation of vast datasets and complex patterns. This seminar aims to demystify these milestones, illustrating their evolution and the underlying principles that make them pivotal in pushing the boundaries of what machines can learn and achieve. Each topic, from perceptrons to transformers, will be explored in detail, emphasizing their historical context, theoretical foundations, and practical applications, anchored by Python examples to bridge theory with tangible skills. In tracing the roots of neural networks, we see a timeline marked by pivotal advancements. The journey begins with perceptrons in the 1950s, spearheading the exploration into mimicking brain functions algorithmically. These models, despite their simplicity, set the stage for the neural networks we study today. Moving into the 1980s, Geoffrey Hinton's development of backpropagation revolutionized the way these networks learn, introducing a method for refining decision-making processes based on errors, a foundational step for complex neural modeling. The advent of convolutional neural networks, or CNNs, marked a significant leap in our ability to process visual information, equipping machines with the capability to recognize and categorize images with remarkable accuracy. This was not just a technical milestone, but a transformative moment in the application of AI, revealing the vast potential of neural networks in understanding and interacting with the world. AlphaGo's victory was a demonstration not just of strategic computation, but of a neural network's ability to outthink human experts in the complex game of Go, underscoring the scope of neural networks' problem-solving capabilities. Each of these milestones not only signifies an evolution in technical sophistication, but also deepens our understanding of neural networks' impact on society and technology. This journey from perceptrons to AlphaGo embodies the iterative nature of discovery in AI, where each advancement builds on the last, pushing the boundaries of what machines can learn. As we delve deeper into each topic throughout this seminar, we'll explore not just the how, but the why behind these developments, grounding our exploration in practical examples and real-world applications, demonstrating the profound implications of neural networks today. This evolution marks the leap from simplistic binary decision-making models like perceptrons to complex architectures capable of solving intricate problems, such as image recognition. Feed-forward networks transcend perceptrons by tackling non-linearly separable problems through the infusion of multiple layers and activation functions. Notably, ReLU and sigmoid play pivotal roles. ReLU enhances computational efficiency by introducing sparsity, turning off unnecessary neurons, thus streamlining the network's operations. Conversely, sigmoid functions are crucial for binary classification tasks, facilitating the network's ability to discern between two possible outcomes. These advancements form the backbone of modern computer vision and similar complex pattern recognition tasks, showcasing the significant transition from simplistic models to architectures capable of understanding and interacting with the world in a more nuanced manner. This slide presents a simplified application of convolutional neural networks, or CNNs, through a Python code snippet performing a convolution operation with a Sobel filter. By demonstrating edge detection, a core task in image processing, this example underlines how CNNs process and interpret image data. The generation of a feature map from this operation is critical, showcasing the network's ability to isolate and enhance essential features for further analysis. This step is foundational for understanding CNN's capability in extracting meaningful information from visual inputs, a cornerstone in their application across various domains. Convolutional neural networks have significantly changed the landscape of how machines interpret visual information. Their efficiency in processing grid-like data structures positions them at the forefront of technologies used in facial recognition, autonomous vehicle navigation, and even medical image analysis. The practical example we just explored offers a glimpse into the foundational operations that enable CNNs to handle these sophisticated tasks. It's this capability that underpins their indispensable role in driving forward technological advancements and influencing everyday life. Through understanding these core operations, we grasp the essence of CNN's transformative impact in the realm of artificial intelligence and beyond. This slide dives into recurrent neural networks, or RNNs, and long short-term memory, or LSTMs. RNNs represented a significant leap in our ability to process sequences, proving pivotal for tasks like text processing and time series analysis by utilizing loops to hold on to information from prior steps. However, they stumbled when it came to learning from long sequences due to the vanishing gradient problem. Enter LSTMs. These networks brought the solution by introducing mechanisms that selectively remember and forget information, which was a game-changer for tasks requiring an understanding of long-term dependencies. The transformation from RNNs to LSTMs underscored the ongoing advancement in natural language processing and machine translation. By solving the limitations of traditional RNNs, LSTMs have not only paved the way for more sophisticated and accurate models, but also set the stage for the emergence of transformers. These shifts mark significant strides in our collective journey to equip machines with the ability to effectively understand and process sequential data and human language. Transformers have ushered in a new era in AI, particularly in how we approach natural language processing. This leap forward is anchored in their key innovation, the attention mechanism, allowing models to prioritize different portions of input data for a more nuanced understanding and interaction. Since their inception in 2017, transformers have not only redefined benchmarks across a variety of NLP tasks, but have also introduced a paradigm shift with their capacity for parallel processing. This has facilitated a rapid acceleration in model scaling and performance across domains, expanding their utility far beyond language tasks to areas like genomics and real-time communication. The efficiency and adaptability of transformers, combined with their cutting-edge applications, exemplify the transformative power of these models. Their ability to efficiently train on extensive datasets has broadened the scope of what's achievable, making real-time applications and complex data interpretation more accessible and effective. In this slide, we're delving into the core principles behind transformers and witnessing their impressive range of applications, from transforming language translation services to advancing scientific research. Neural networks have sparked groundbreaking advancements across various sectors. In autonomous vehicles, convolutional neural networks, or CNNs, empower machines with the capability to process and interpret visual information, revolutionizing transportation. In the financial world, long short-term memory networks, or LSTMs, have boosted the accuracy of stock trend forecasts, showcasing their potent analytical capabilities. Precision agriculture benefits from neural networks, optimizing crop yields through intelligent resource management, demonstrating technology's transformative role in even the most traditional sectors. These applications underscore the diverse utility of neural networks, addressing complex challenges and enhancing operational efficiency across the board. As we witness neural networks reinventing industries, it's imperative to also focus on future challenges. Addressing issues like enhancing energy efficiency and mitigating data bias are critical. These efforts aim at not only refining neural network models for better performance, but also ensuring fairness and inclusivity in AI applications. This continual evolution propels us to actively contribute to shaping the future of neural networks, positioning this field as an exciting frontier of both opportunity and responsibility. Neural networks, drawing inspiration from the intricate workings of the human brain, have paved a remarkable path of innovation in the realm of technology. From their initial inception as perceptrons in the 1950s to the complex architectures of today's deep learning models, they demonstrate an unparalleled capacity for automating and refining pattern recognition. This evolution bears witness to neural networks' indispensable role in deciphering and managing extensive datasets across diverse applications. Today, we stand on the cusp of new advancements, from enhancing image recognition to mastering the nuances of natural language processing. This seminar aims to dissect these developments, from the foundational groundwork laid by perceptrons to the latest in transformer technologies. Through detailed exploration and practical Python examples, we bridge the gap between theoretical constructs and real-world applications, illuminating the mechanics that empower neural networks to interpret complex patterns. Our journey is not just an academic exercise, but a hands-on experience designed to equip you with both the understanding and the skills to navigate and contribute to this dynamic field. As we delve deeper into each topic in subsequent sessions, we'll uncover the historical context, theoretical underpinnings, and practical implementations, showcasing the profound impact of neural networks today.